Good morning, everybody. And my name is Huayu Li. I'm coming from UNC Charlotte. And this work is joined with Hongke Zhao. And today I'm going to talk about checking the dynamics in crowdfunding. And this is the outline. First, let's look at the question, what is crowdfunding? Crowdfunding is an internet fundraising mechanism by raising monetary contributions from the crowd for the project or the ventures. There are a lot of applications for crowdfunding, such as the Indiegogo, this platform. In 2015, it was estimated that over 34 billion were raised worldwide in this way. Compared with that, the venture capital industry invests around 30 billion on average each year. It has shown that it is very important for the crowdfunding. There are two important concepts in crowdfunding, that is campaign and perk. When an individual wants to raise money on these platforms, she will create a campaign for this project. And each campaign will have different types of the rewards with different prices. We call this type of reward as perk here. Consequently, the backers can choose different perks to make different monetary contribution for the project. Let's look at this picture. And here, this is a campaign for the project named the smallest, most powerful speaker. And we can see there are different types of perks here, including $49 and $70. And we also can see some information about the backers here. As the crowdfunding is more and more popular, let's look at the interesting research problem we are concerned about and the data we have already collected. And actually, the funding sequence is a two-level time series, including the dynamic of the funding amount on the perks and the dynamic of the summarized funding amount on this campaign. In reality, the successful prediction for the dynamics in crowdfunding can benefit all of these three parties. First, the creators can update their campaign information and adjust their perk settings in time. Second, the backers can make better decisions, and at the same time, the platform operators can also provide better service. Recently, a lot of efforts have been made for crowdfunding. For example, there are some research work focusing on predicting the status of the campaign, that is to predict whether a campaign is successful or not. And also there are some recent work pay more attention on identifying the important factors about the crowdfunding. Of course, there are some other applications, such as the campaign recommendation and the backer recommendation and so on. As we know, the crowdfunding is more and more popular. However, there are some important challenges. First, there are some hierarchical dynamics in such longitudinal crowdfunding data. From the data, we can observe that the daily funding amount of the campaign and the perks may change over time. Thus, it is non-trivial to model such kind hierarchical dynamics. Second, there are a lot of different factors that will affect the prediction about the campaign and the perk, such as the decisions of the visitors, the social features, the prices, and so on. The last challenge is the heterogeneity. From the data, we also observe that the dynamics may vary a lot among different campaigns, different perks, and even different funding phases. Therefore, it is quite challenging to model such prediction in crowdfunding data. To address these challenges, let's look at our data that we have already collected. The data we used is collected from the Indiegogo website. This is a quite popular website for the crowdfunding. And we have the daily funding information ranging from 2011 to 2016. And this table shows some information about data. We have the campaign information, the perk information, the user information, and so on. Totally, we have 24 campaign side features and 30 perk side features. And I summarize here. And we have different type of features, including the numerical feature, the categorical type, and the text feature, and so on. After introducing the data, let's look at some details about the methodology. I formulate the problem here. That is, we want to predict the daily funding amount of the campaign and the perks based on previous campaign sequence and the backer sequence and the corresponding features. That is, we want to learn such function. We summarize our method here. Specifically, we propose a single regression and the switching regression to predict the daily funding amount of the campaign and the perks. And then, based on the estimation in each level, we propose to imply a revision matrix to combine these predictions. Now, let's look at the single regression and the switching regression. We assume there are two types of visitors here. That is, the infected visitors and the spontaneous visitors. But by the reason of the different assumption for the different type of visitors, we propose to model them in different way. For the infected visitors, we refer them as the visitors who are affected by previous backers. Therefore, we propose to use the regression method to capture the influence of the previous backers. And for the spontaneous visitors, we propose to imply the Poisson distribution to capture those users who are attracted by the properties of the campaign. Therefore, the total visitors can modeled by summing these two types of visitors together. After estimating the visitor number, we can predict the backing probability. Here, we propose to use the Cox proportional hazard function to estimate such backing probability, which is the instantaneous rate of the occurrence of the backing behavior. Specifically, we will use the density function to estimate this backing probability. Hence, we can estimate the daily funding amount of the perks by multiplying the unit price and the estimated visitor number and the backing probability. And similarly, we can also estimate the daily funding amount of the campaign in similar way. That is, multiplying the visitor number and its corresponding backing probability. In addition, from our data, we observe that the funding amount sequences of the campaigns and the perks may form different clusters, which will have different dynamic patterns. Therefore, we propose to use the cluster technique to group the similar campaigns and the perks together. And in each cluster, we use different parameters to indicate the different dynamic patterns. Based on this idea, we can learn the parameters by EM algorithm. Specifically, in each iteration, we have two steps. In the first step, we will update the cluster index for each data point. And then, in the second step, we will update the parameters using the gradient descent method. And then we can do this process iteratively until convergence. Right now, we can use this kind of method to estimate the daily funding amount of the campaigns and the perks. Next, I'm going to combine them together using a revision matrix. We propose to use such revision matrix to combine these two-level estimations together. And it can guarantee to provide an optimal solution for the independent estimations. Finally, we can obtain the estimations for the campaign and the perks, like this one. Next, this is the basic idea about our method. So next, let's show you some experimental results to demonstrate the effectiveness of our models. And this table shows the data statistics of our data. Specifically, we divide the data into two parts according to the funding time. One part is about the funding time is 30 days. Another one is 60 days. And we adopt a lot of baseline methods to evaluate models' performance. And here are the baseline methods we use in the experiments. For the evaluation metrics, we use the MSE and MRSE. Next, let me show you some data analysis. And these are the results. They are the data analysis associated with the daily funding amount of the perk and the campaigns, and the daily back number. From the results, we can observe some interesting observations. First, the adjacent daily funding amount is highly correlated. And second, the series of both campaigns and perks at different funding time will have the dynamic patterns, which also motivate us to use the clustering to choose different parameters for different patterns. And these are the results of our methods versus of the baseline method in terms of MSE and MRSE. And here, from the results, we can get some conclusion. First, our method is much better than others. And second, it also demonstrates the effectiveness of the clustering technique for funding sequences. In addition, we also show some experimental results with different parameter tau, which indicate how many previous days data we will use for each data example. And from the result, we can observe that as tau increases, the performance is better. It indicates that the more previous days data we consider, the better results we will have. And from this result, we can also see that our method outperforms others. And finally, I will conclude my talk. We propose to study the dynamics in crowdfunding, including to predicting the daily funding amount of the campaigns and the perks. Specifically, we collected massive real-world crowdfunding data, which can benefit the research communities. With this kind of data, we propose a two-level hierarchical solution framework. Specifically, we propose two different regression models to capture the dynamics in crowdfunding. And based on the estimations in each level, we propose to employ a revision matrix to combine their independent predictions. So that's all. Thank you.